Lab, calculate the bouncing ball height. So this is an illustration what is involved with this lab. So first we need a bouncing ball, and we need to know a height that you are going to drop this bouncing ball. So when this bouncing ball hits the ground, it's going to bounce back. So actually it's going to bounce back several times, but we are going to consider just the first bouncing back, the first time. Okay, so in this illustration here, the first thing you're gonna do, we are going to find the velocity a ball hits the floor. So we are gonna drop this ball. This student taped 2 meter sticks back to back on the wall and drop the ball on this height, 2 meters. And when the ball hit the ground, we calculate the final velocity when hit the ground, and this final velocity will be the initial velocity when the ball bounces back and is going to stop before changes direction. So when it stop, the final velocity when bounces back is 0. So we are going to use some data from students. They did this lab in classroom. So we use here in classroom two different types of ball. When we use a golf ball, and the second one use a ping pong ball. So I'm going to explain with details how we did the golf ball, and you are going to use this explanation and complete the ping pong ball. Okay, so we are going to start by calculating the final velocity the ball hits the ground. So we are going to complete this table 1 based on this picture. So our initial velocity here is 0. Our final velocity, this is what we are looking for. Our distance is the 2 meters. And our acceleration is positive 9.8 meters per second square because the velocity is increasing. And the time, we don't know, just let's put a dash, or you could put a T if you want to. Let's put a T here. Okay. So our goal with this data is to calculate the final velocity. So we are going to use a formula, one of the equations formula that does not involve time because we don't have this information. So we are using this equation, the final velocity square is equal initial velocity square plus 2AD. So our final velocity square is initial velocity, which is 0, plus 2 times A, which is 9.8, and D is 2. So the final velocity square, so we multiply all these values, is 39.2. Now we are going to square root both sides, and our final velocity is 6.26 meters per second. So that's the velocity the golf ball hits the ground. Now, for our second part is when the ball bounces back. So now our initial velocity here is the final velocity when hit the ground, which is 6.26. So 6.26 meters per second. Our final velocity is 0 because we are considering the first bounce. So it's going to stop. Our distance or height, that's what we are looking for. The acceleration is negative 9.8 meters per second square because it's decelerating. And the time, so this time was provided by the in-class students. So I pick from one group 0.36 seconds. Because it was very challenging to measure this time. I ask students to measure when the ball hit the middle stick when bounces back. So right here on this height, they measure and was 1.52 meters. So we are going to keep this number as a reference, even though we are calculating this height. So students in class, they measure to make sure that the result is going to be in this range. Now we need to find a formula that include distance and include time. So that will be our choice. Distance is VIT plus half AT squared. So D is, our VI is 6.26 times the time, 0.36. Now, because the acceleration is negative, we are going to move this negative here because all this is time, acceleration time, they're multiplying. So the negative goes here. So half A 9.8, because the negative, I move here. The time now is 0.36 square. So this is just like getting the calculator and plugging all these numbers. So it will be 6.26 times 0.36 minus, this is 4.9, 9.8 divided by 2, 4.9 times 0.36 squared. So our answer here for all these products here is 1.6 meter. Okay, so that is our calculated. Comparing with what we measure is pretty close range. So that was a good time that we measure, this group measure. Okay, for the ping pong, we are going to do the same, basically the same thing. So you are going to notice, regardless of the weight of the ball, everything falls with the same. If it falls from 0, if it's dropped, it's going to fall with the same ratio, which is 9.8 meters per second square. Is going to add every second 9.8 meters per second, the speed. So we should expecting the final velocity for the ping pong will be exactly the same. So here will be 0, VF, 2, and 9.8 meters per second square, and the time. So you just copy the same results for this table 1 on table 3. Now, the ping pong is a different material. So when bounced back, the height recorded when bounced back from some students depends the area where they were working. Some they work on concrete, some they working on a type of a PVC tile. So all kind of affect how much bounces back. But for this example, one group was 1 meter and 4 centimeters, so 1.04 meter. Okay, and the time for this group is 0.27 seconds. So you are going to use those two information and do exactly the same that we did here. Okay, so on the back of the page, I ask for a conclusion. So write a conclusion based on the experiment. You can look the picture that I provide on your assignment and describe the picture and incorporate terms and definitions that you have learned about vertical downward motion and vertical upward motion.